Hi, hello dear students, welcome to our channel Maths with Panindra. In this video, we are going to discuss about definite integral as sum. In definite integration, we have one of the important concept. This is not only for intermediate boards, but also JEE Mains and MSET. We can expect one of the questions in MSET examination guarantee. And in IPE boards, intermediate boards, Telangana or Andhra Pradesh, we can expect this type of question. First, I will explain the procedure. What are the steps we have to follow to do such type of problems? After that, I will explain different examples and exercise 7B. In the 7B exercise from 8 to 15, like some questions are there related to this concept. Let us have a discussion the concept. To transform the given sum as n tends to infinity into a definite integral, we proceed along the following steps. These are the following steps. In the first step, what we have to do is express the given sum in the form sigma or summation I equal to 1 to n 1 by n f of I by n form, or sigma I equal to 1 to n minus 1 1 by n into f of I by n. Either this form or this form, you have to get it. So in the step 1, express the given sum into this form, summation form. In the second step, what we have to do is you replace I by n with x. In place of I by n, x. In place of 1 by n with dx. In place of I by n, x. In place of 1 by n, dx you have to write. Then you will get it f of x into dx. Later on, in the step 3, calculate the lower limit and upper limits of the integral. How to calculate lower limit and upper limit? Lower limit, LL means lower limit. Limit n tends to infinity, initial value of I divided by n, total values. Usually this limit is 0, obviously it will come. Initial value is always I is equal to 1, I is equal to 1. So initial value of I means whatever the first number of I, it will be always 1 only. So 1 by n, as n tends to infinity, 1 by n tends to 0, no? In the limits first year mathematics 1B, we learned that as n tends to infinity, 1 by n tends to 0. So that's the reason usually this limit goes to be 0. Lower limit will becomes 0. Now come to UL, upper limit. Limit n tends to infinity, final value of I divided by n. Final value of I. Suppose I is equal to 1 to n. Final value is what? N. So n by n, which is equal to 1. If final value is n, we are getting the upper limit is equal to 1. Other than n, it will be there like Pn plus or minus q. That also I will give example here, students. That time the answer is P. Here whatever n coefficient is there, that will come here. This is about step 3. According to steps, I will give the example. Don't worry about the procedure. Next, come to the step 4 of finding lower limit and upper limit. Replace sigma I equal to 1 to n, limit n tends to infinity, sigma I equal to 1 to n, with integral 0 to 1. Thus, we get limit n tends to infinity 1 by n, sigma I equal to 1 to n, f of I by n will becomes. In place of limit n tends to infinity, sigma I equal to 1 to n, it will become integral 0 to 1, no? I already said that I by n with x and 1 by n with dx, so it will become f of x into dx. So here it will becomes dx. So this is the way. Now come to the example. Evaluate limit n tends to infinity 2 power k plus 4 power k plus 6 power k plus and so on to n power k. divided by n plus 1, n power k plus 1. So first, dear students, given limit you write it. Limit n tends to infinity 2 power k. Here all are even numbers now. Here 2n means 2 into n. Even 2 can be written as 2 into 1 whole power k plus 4 can be written as 2 into 2 whole power k. 6 can be written as 2 into 3 whole power k plus and so on 2 into n whole power k divided by a power m plus n. In the denominator n power k plus 1 is there. We can write it as n power k into n power 1. N power 1 means what? N. I hope everyone understand. Limit n tends to infinity. AB whole power m means a power m into b power m. So 2 power k into 1 power k plus 2 power k into 2 power k plus 2 power k into 3 power k plus and so on 2 power k into n power k divided by n power k into n. In numerator 2 power k you have to take common. Limit n tends to infinity 2 power k if we take out common, the rest of the terms 1 power k plus 2 power k plus 3 power k plus and so on n power k divided by n power k into n. Clear? Everyone understand now? Now come to first step. Express the given sum in this form. So observe carefully. Limit n tends to infinity 1 by n. I want to write 1 by n also separate. 1 by n. 1 by n is there here. 1 by n. The remaining, even 2 power k is also there. The 2 power k you write it separately. 2 power k. Here 1 power k plus 2 power k plus 3 power k and so on n power k. Observe carefully. 1 by 1 power k plus 2 power k plus 3 power k plus and so on plus n power k by n power k. What is the meaning of this? Each and every term dividing by n power k only, no? So can we write like this? 1 power k by n power k plus 2 power k by n power k plus 3 power k by n power k plus and so on n power k by n power k. We can write it. In the next step, limit n tends to infinity 2 power k into 1 by n. This can be written as 1 by n whole power k. A power m by b power m, a by b whole power m, 2 by n whole power k plus 3 by n whole power k plus and so on n by n whole power k. As n tends to infinity, 2 power k is constant, we can take outside. It's not no need. 2 power k, limit n tends to infinity, 1 by n. This bracket value I am writing as a summation. See here, sigma I is equal to 1 to n, 1 by n, 2 by n, 3 by n and so on n by n, no? So 1, 2, 3 and so on. In terms of I want to write it. I by n whole power k. I power n, you can write it better. Here in terms of k is there, is k only here, students. I is equal to 1, substitute 1 by n whole power k. We got it now. I is equal to 2, substitute 2 by n whole power k. I is equal to 3, substitute 3 by n whole power k. Everyone understand? So first step completed. This is the for understanding purpose I wrote. Otherwise you can write directly also. For your student convenience I wrote here, students. So step 1 completed here. Here we applied step 1. In exam, no need to write, for your understanding purpose, I am giving. After step 1, what we have to do? I by n replace with x, 1 by n replace with dx. So I by n value is x, 1 by n replace with dx, f of x dx. So we are going to write this as, even limits also we can find. I by n is equal to x, and wherever 1 by n and dx, 1 by n is there, no, it will be dx. Limits also calculate here only. Lower limit n tends to infinity, initial value of I is what? 1. By total n, how many values are there? N tends to infinity, 1 by n value is what? 0. Next, upper limit n tends to infinity, final value of I is what? N, by n is equal to 1. Obviously we are getting as 1. So lower limit is 0, upper limit is 1. Now come to step 4. Step 1 completed, step 2 also completed here. This is step 2. This is about step 3, these two. In step 4, what we have to do? Limit n tends to infinity, 1 by n term in terms of integration. So 2 power k, limit n tends to infinity, 1 by limit n tends to infinity and sigma. These two values will make it as sigma 0 to 1. So these two terms will become integral 0 to 1. Lower limit to upper limit. Here lower limit is 0, upper limit is 1. Next, 1 by n and this value will becomes, I by n is equal to what? X power k. In place of 1 by n, dx. So 2 power k. What is integral x power n formula? X power n plus 1 by n plus 1. So x power k plus 1 by k plus 1. Applying the limits 0 to 1, which is equal to 2 power k. In place of x, substitute 1 by 1 power k plus 1 is 1 power anything is 1 only. Minus, in place of x, substitute 0. So that is equal to 2 power k by k plus 1. I hope everyone understands, dear students. The value of this one is 2 power k by k plus 1. I will take different examples. I will discuss now. Yeah, the next question, dear students. Evaluate limit n tends to infinity, sigma I equal to 1 to n, 1 by n into n minus I by n plus I, by using the method of finding definite integral as limit of sum. Just now we discussed the one procedure and one example. Now in the textbook examples I am explaining, which are also very important. We may get in competitive exams directly these questions as MCQs. You can concentrate, dear students. So first we have to write the given limit. Limit n tends to infinity, sigma I is equal to 1 to n, 1 by n into n minus I divided by n plus I. Here I by n term is not there in this. Sigma is already there. In the previous question we got sigma by expanding the terms and all. Here sigma they provided. We need to get I by n terms. How to get this I by n term is, limit n tends to infinity, observe carefully, sigma I is equal to 1 to n, 1 by n, n take out common, n into 1 minus I by n by n into 1 plus I by n. So here n get cancelled, which is equal to limit n tends to infinity, sigma I is equal to 1 to n, 1 by n, 1 minus I by n by 1 plus I by n. After getting I by n, what we have to do? Where I by n is equal to x, you have to take it. And wherever 1 by n is there, you have to replace with dx. After that, wherever 1 by n is there, what you have to write? Dx. These are the simple tricks, dear students. And we need to calculate definite integral limits. So lower limit and upper limit. So here lower limit. Limit n tends to infinity for starting value, initial value of I. Initial value of I is what? 1 by total values n. Limit n tends to infinity, 1 by n value is what? 0. So lower limit will be 0. Next, upper limit. Limit n tends to infinity, final value of I. Final value of I is what? N by total values n. So n by n means what? 1. So lower limit and upper limit, we got it now. Compulsory you should write it, dear students. So later on, in place of limit n tends to infinity, sigma I equal to 1 to n, replace with integral 0 to 1. In place of 1 by n dx, wherever I by n is there, x. So it will become 1 minus x by 1 plus x dx. Over. Normal integration from here. How to integrate this type of problem? 0 to 1 integral 1 minus x by 1 plus x. I want to solve this type of problems, important for 2 marks in definite integration. Other than summation is definite integral as limit of sum. Denominator, numerator, in terms of denominator we have to write it. So 1 plus x is there now in the denominator. I want to get in numerator also 1 plus x term. So integral 0 to 1 minus x. To get in the numerator, in terms of denominator, we are subtracting 1 and adding 1 divided by 1 plus x. So how it will come? I will tell that. Integral 0 to 1 plus 1, 2. From these two minus take common, minus of 1 plus x, am I right? Divided by 1 plus x into dx. In the next step, we can split into two integrals and then integrate. So integral 0 to 1, 2 by 1 plus x into dx minus integral 0 to 1 plus x divided by 1 plus x into dx. Everyone understand, these students? I hope that. So two constant we can take outside. Integral 0 to 1 by 1 plus x into dx. So here 1 plus x get cancelled, minus integral 0 to 1 dx. So which is equal to 2 into integral 1 by x. Integral 1 by x is log mod x. So log mod 1 plus x. After that we can apply the limits, dear students. 0 to 1 minus integral dx is x. Applying the limits 0 to 1. So 2 into, wherever x is there, replace with 1. So log of 1 plus 1 minus log of 1 plus 0 minus 1 minus 0, which is equal to 2 into log 2 minus log 1 minus 1. Log a minus log b, log a by b. So which is equal to 2 into log 2 by 1 minus 1, that is equal to 2 into log 2 minus 1. Still, if you want to write more steps, we can write it as log 2 square minus 1, that is equal to, in terms of e also we can write it. So log 4 minus 1 can be written as log e to the base e, even for this also base e. So we can write it as log 4 to the base e. Otherwise leave it like this, even till here also correct answer, dear students. If you want to write more information, you can write in that way. Better to write here till here, that is enough. We'll move on to the another question. The next question. Total 3 to 4 examples are there. That 3 examples in the textbook and the concept I explained. In the next video, I will give that exercise problems also. I will discuss separate video, dear students, for the convenience. So now come to the question. Evaluate limit n tends to infinity 1 plus 1 by n, 1 plus 2 by n, 1 plus 3 by n, and so on, 1 plus n by n, whole power 1 by n. You remember, dear students, in the limit of some questions, limit n tends to infinity, some value whole power n is there. The given limit, you can assume some constant and taking log on both sides. You remember, very important, taking log on both sides whenever the power will be there, like exponent. So here, so first what I am writing is, let p equal to, I am taking this limit as p, limit n tends to infinity 1 plus 1 by n into 1 plus 2 by n, 1 plus 3 by n, and so on, 1 plus n by n, whole power 1 by n. That is the given limit. Whenever whole power 1 by n terms is there, taking log on both sides. Observe carefully, dear students. Taking log. Log means log to the base e on both sides. So it will becomes log p to the base e is equal to, base e means natural logarithm. Log, here limit n tends to infinity is an operation, no limit. We can take log inside the limit. Limit n tends to infinity, log of 1 plus 1 by n, 1 plus 2 by n, 1 plus 3 by n, and so on, 1 plus n by n, whole power 1 by n. In logarithms, one of the property, log a power m. Log a power m means what? M into log a. So which is equal to limit n tends to infinity, by applying the logarithm properties, log a power m, that m will become here now. So 1 by n log 1 plus 1 by n into 1 plus 2 by n into 1 plus 3 by n, and so on, 1 plus n by n. Observe, dear students, 1 plus 1 by n, 1 plus 2 by n, 1 plus 3 by n, and so on, 1 plus n by n is there. These product we can write as the sigma value and so on value. So limit n tends to infinity 1 by n log sigma I is equal to 1 to n 1 plus I by n. Am I right? If we take I is equal to 1, 1 plus 1 by n, we got it. I is equal to 2. this sigma, sorry dear students, first sigma here, I is equal to 1 to n log of this y. I is equal to 1, substitute log of 1 plus 1 by n. Next plus I is equal to 2, log of 1 plus 2 by n, and so on. Log a plus log b plus log b, log a. This you know anyway product it will be. I hope everyone understand. So log, what I did is log of this value. Before log I am taking sigma or summation. After that what we have to write? Wherever I by n is there, replace with x. Wherever 1 by n is there, dx. Later on, limit n tends to infinity, sigma I is equal to 1 to n is there, integral. First we will find out the limits. Lower limit and upper limit. Lower limit is, first I will calculate lower limit. Limit n tends to infinity, initial value of I, here 1, by total number of divisions, n. N tends to infinity, 1 by n value is always 0. Limit n tends to infinity, 1 by n is 0. Upper limit, limit n tends to infinity, final value of I, n, by total number is n. N by n is equal to 1. Limit of constant is constant. So, replace with these values as integral 0 to 1, lower limit to upper limit. 1 by n replace with dx, I by n replace with x. So log 1 plus x into dx. Everyone understand now? Integral log x is there. Integration by parts you can take, dear students. We know that in the procedure of integration, this completely the value of log p to the base e. Integral 0 to 1 log of 1 plus x dx. Here, integral 0 to 1 log of 1 plus x into 1 into dx. By using integration by parts, this is f of x, this is g of x. By using integration by parts, here I will write formula for the students' convenience. Integral fx into g, like means f into gx. F into integral gx dx minus integral f dash of into integral gx dx. So this is the formula. By using integration by parts, so here limits are not there, here limits is there. So we can apply limits here. Whatever the limits are there, limits we can write it here. Suppose a to b is there, here a to b. Just integral a to b, here a to b. This is f of x. By using ILATE formula, here we are going to apply ILATE. You know that in integration by parts, ILATE formula we apply. F of x is logarithmic. So f of x means log 1 plus x into integral 1 into dx. Applying the limits 0 to 1 minus integral 0 to 1 f dash of x. Log 1 plus x derivative is what? 1 by 1 plus x into integral g of x, integral 1 into dx, whole dx. Everyone understand? So which is equal to log 1 plus x into integral dx is x, applying the limit 0 to 1 minus integral 0 to 1, integral 1 into dx is x by 1 plus x into dx. In place of x, upper limit substitute. So log p to the base e is equal to, so first upper limit in place of x, log of 1 plus 1 into 1 minus log 1 into 0. Anyway, this is completely 0 except this one. Minus integral 0 to 1 x by 1 plus x into dx. So which is equal to log 2, log 1 plus 1 is log 2, log 2 into 1 is log 2 minus log 1 value 0, already 0 is there, minus integral 0 to 1. To solve this type of problems in the previous question also we discussed, denominator 1 plus x, I want to get numerator also 1 plus x. So by adding and subtracting plus 1 and minus 1, 1 plus x minus 1 divided by 1 plus x into dx. We are adding and subtracting. So which is equal to log 2 minus integral 0 to 1 plus x divided by 1 plus x into dx, minus into minus plus integral 0 to 1 by 1 plus x into dx. So which is equal to log 2 minus log 2 means log 2 to the base e. Here these two will be cancelled, integral dx is x, can I write directly? Okay, for your convenience I'll write it 0 to 1 dx plus integral 1 by x means log mod x, here compulsory we should write. Applying the limits 0 to 1. So log 2 to the base e minus integral dx is x, applying the limit 0 to 1 plus in place of x upper limit 1, so log 1 plus 1 minus log 1 plus 0. So which is equal to log 2 to the base e minus upper limit minus lower limit in place of x 1 minus 0 plus log 2 minus log 1. Log 2 means log 2 to the base e, log 1 means log 1 to the base e. So that is equal to log 2 to the base e minus 1 plus log 2 to the base e minus log 1. Log 1 means 0. You write it. Log 2 to the base e twice. 2 times of log 2 to the base e minus 1. That also like previous problem. Log 2 square to the base e minus 1 can be written as log e to the base e. Log of to the base of same value is always equal to 1. So that I am writing. Again log a minus log b formula I am going to apply. Log 2 square divided by e to the base e. That is equal to log p to the base e. So by comparing, I want p value now. So by comparing log functions, we cannot cancel. So p equal to 2 square by e. That is p equal to 4 by e. 4 into 1 by e means e power minus 1. Therefore, p equal to the limit, you can write it. Limit tends to infinity. Keep bracket. 1 plus 1 by n. 1 plus 2 by n. 1 plus 3 by n. And so on. 1 plus n by n. Whole power 1 by n equal to 4 e power minus 1. This is the way we can do, dear students. By doing problem by problem, you will get interest. Number of times if you practice, these questions are very interesting in integration. The other questions, exercise 7b questions, I will make another video for your convenience. First, you prepare you learn the procedure and these 3 examples. Later on, we will discuss the other question. And not only this one, those who are watching first time, please do subscribe and share to your friends. If you are really like, you can share to your friends and relatives. You can subscribe and go to the playlist. Number of MSET, JEE Mains, BITSAT type questions are there in Maths A, Maths 2A, Maths 2B, Maths 1B. You can utilize and you can share to your friends also. Why? Because your friends also writing some competitive examinations. For their convenience, you can support. Thank you all of you. Jai Hind, Maths with Panit.